Graphing cubic, square root, and cube root functions. Here's a bit of a review. You should be able to evaluate x squared when x equals 7. What is that? How much? X squared when x equals 7. 49. The square root of x when x is 81. 9. Evaluate x cubed when x is 5. Calculator if you don't know it off the top of your head. It's not a game show. 125. You get that by doing 5 times 5 times 5. That's 5 cubed. What is the cube root of x when x is 27? It is 3. What number do you multiply together? The same one 3 times to get 27, and it is 3. If you don't know how to find that on your calculator, then I'll show you. On your calculator is a caret button. It's a little symbol that looks like that. You put 27 in, hit that button. Left hand parenthesis, 1 divided by 3. And then hit enter. It gives you back 3. That's how you find a cube root. Whatever the root is, you put it under 1 in the parentheses. Now for this table, y equals x squared and y equals the square root of x. We have to fill in the table. What is, we'll start up here for this one. If I square x, what do I come up with? 16. What is the square root of x? How much? 2. Now, I have this. What is 2 squared? 4. What is the square root of 2? 2 decimal places. 1.41. What is 0 squared? 0. What is the square root of 0? 0. What is the square of negative 2? 4. What is the square root of negative 2? It comes back to be an error. What is the square root of negative 4? Or actually, what's the square of negative 4 first? It is 16. What is the square root of negative 4? It's an error. Those are the same values that we came up with. So what do you notice about the y values? These are the y values that we came up with here. What do you notice about them? From this column to this column, we are comparing the two columns. What do you notice between the two? Are these all numbers? Are these all numbers? So this is different. Whenever x is negative, you come back with an error when you're finding the square root of x. All values are positive for y equals x squared. And then all negative values come back with an error when you find the square root. That's the difference between the two. Why are all y values for y equals x squared positive? The y values are all positive for the x squared because they're obtained by squaring x. Why do all negative x values produce an error for y equals the square root of x? If I'm squaring this, I'm multiplying it by itself. Multiply it 2 times. But what if I had this? When you square two numbers, you're multiplying the exact same thing together. What 2 things can I multiply that are identical that will give me a negative number, which is this? Are there 2 identical numbers I can multiply here and here to come up with this? No, there's not. That's why it comes back to be an error. No real number, when squared, produces a negative result. What is the domain of y equals x squared and y equals the square root of x? In case you have forgotten, we went over this before. You have a function. For example, let's say it were 3x plus 2. The domain is what you're putting into it. The range is the answer that comes out. Domain goes in, range comes out. So is there any limit on the types of numbers that I can put in here for x and square them? There's no limit on the numbers for x that I can put in and square them. Is there any limit for the numbers for x that I can put in and find a square root of those numbers? Is there anything I cannot use? Can't use negatives, that's right. So the domain for y equals x squared is all real numbers. There's no limit. You can put in anything. But for y equals the square root of x, it has to be greater than 0, or greater than or equal to 0. What is the range of y equals x squared and y equals the square root of x? In other words, what is coming out? Look at the y values. Positive, yes. Could they be 0? Yes. So the range for y equals x squared is y is greater than or equal to 0, and for y squared equals the square root of x, it is y greater than or equal to 0. Compare the domain and range of y equals x squared and y equals the square root of x. So y equals x squared. They have to be all real numbers for the domain. For y equals the square root of x, it's got to be x greater than or equal to 0. And then the range for both of those is y greater than or equal to 0. What is the result if we take the square root of x? So if I find the square root of x squared, I'll end up back here with these, but for this one, I'll end up back at -2, because it's shown to us that's what was given, that we had to square to go this way with that. So in reality, you could have the square root of 16 equal to plus or minus 4. And another answer is if x is negative, then the result is -x. And if x is positive, then it is just x, whatever it was before. For this lesson, what we're going to figure out is that the square root of x squared is simply going to be the absolute value of x. Absolute value is when Whatever number you put in those brackets, it comes out positive. We're just going to deal with that. Now we have to graph y equals x squared. You'll have to do this on a quiz. This is y equals x squared, and we've done this before. We've had tests over equations more difficult than this. Look at how it's constructed. I'll do this in a black marker. X is what you're putting into it, and then you square it and you get back an answer. So if I put in 0, here is 0 on the x-axis. If I square 0, I get back 0. So my point is 0, 0. That's where it's at. If I put a 1 in and then I square it, what do I get back? 1. So I go over 1, up 1, make a dot. If I put a -1 in and I square the -1, what do I get back? +1. So I put in a -1, I go back -1, and then up 1, because 1 was the answer that came out. If I put in a 2 and square it, what do I get back? 4. So I come up here, there's another dot. If I put in a -2 and square it, I get back a +4. If I put in a 3 and square it, and it's going to go up until I don't have any more room left, but I'll get back a 9. That is how you create the graph of y equals x squared. Notice it's a curve, it is not a point down at the bottom. We're going to do the same thing with y equals the square root of x. What values can I not put in for x? Negative. Cannot put in negative values. So if I put in a 0, what is the square root of 0? 0. So my point is 0, 0. If I put in a 1, so I'm coming over here to 1. If I put in 1, what is the square root of 1? 1. So here is 1 there. 1, 1 is the point. If I put in 2, what is the square root of 2? 1.41, and that is approximately right here. If I put in a 3, what is the square root of 3? 1.7 something, so it's approximately here. And if I put in a 4, the square root of 4 is 2. How about I skip to a perfect square, such as 9 over here? The square root of 9 is 3, so there's 3 right there. That's how this is created. And it keeps going up like that, ever so slightly. Now graph both y equals x squared and y equals the square root of x together on the same graph. And if we repeat the process that we just did, then this is what's going to happen. Can you explain why they intersect at 0, 0 and 1, 1? If I put 0 in for x squared and I square 0, what do I get back? 0. If I put 0 in for the square root of x, what's the square root of 0? 0. So that's why they both share that same point, because it creates the same result in each case. If I put 1 in for x squared, what do I get back? 1. And if I put 1 in for the square root of x, I get back 1. So they create the same result. That's exactly what we just said there. What is special about the graphs between 0, 0 and 1, 1? What is special is that these points create an area in which the shape is going to be symmetric. I'm going to try my best to put this line in there. That's off a little bit. There we go. It creates a symmetric figure in there where you have the same on this side as you have on that side, or in other words, it is a reflection. Those pieces, those graphs are a reflection of each other. So what predictions can we make about y equals x cubed and y equals the cube root of x? Is there anything we can figure out about those from what we've already done with the square? So the domain, would there be any restrictions on what we could put in for x cubed? Could they be any number? We could put a negative in, we could put a positive in, it could be 0. And what about y equals the cube root of x? Can we put negative numbers in for x, and positive, and 0? So it should be all real numbers. And it is. We have no restrictions on what we can put in for x for the domain. Now what about the range? Is there any limit to what can come out for the answers? Can the answers be positive? Can they be negative? They can be 0. So it should be all real numbers for y equals x cubed and y equals the cube root of x. Alright, create a table of values for y equals x cubed and y equals the cube root of x. So here's the table, and we have to fill it in. Let's start with -8. So if I start with -8 and I cube a -8, that means I'm multiplying -8 times -8 times -8. What do I get back? -512. What is the cube root of -8? Porter already did it. The answer is what? -2. If you still don't know how to find the cube root on your calculator, you put your number in parentheses, then after that hit the caret button. And then inside of a set of parentheses you put 1 over whatever that root is. In this case it's 3. Alright, if we're going to cube -2, we multiply -2 times -2 times -2, you should get -8. And if you cube -1, you'll get -1. If you cube 0, you get 0. 1 cubed is 1, 2 cubed is 8, and 8 cubed is 512. Now if you do the cube root of x, you'll end up with a 2, and this would be a 1 and a 0, but the cube root of -1 is -1. The cube root of 2, that's going to come out to be a decimal. What is it to 2 decimal places? So we'll have 1.26 here and a -1.26 there. Okay, so if we graph y equals x cubed, this is what it would look like. And we'll zoom this in as much as we can. The obvious points, we'll start at 0. If I cube 0, I just get 0. So that's why we have a point at 0, 0. This is 1 here. This is a -1. That's a 3. If I cube 1, if I cube a 1, then I come up with 1. If I cube a -1, I come back with -1. And it's going to follow that pattern from the table of values we just did. So it's got this little thing going on here where it kind of comes up, flattens out a little bit, then continues on upwards. And if you graph the cube root of x, it's going to look like this. If I put 0 in, and the cube root of 0 is 0, so that's why we have a 0 here. And some of the more obvious points, if I put in an 8, 8 is right here. The cube root of 8 is 2, so there's a point there on 2. Here's negative 8 back here. The cube root of negative 8 would be negative 2. That's how we come up with this strange looking graph like that. It's similar to the other one, except it goes out this way. The other one was coming up. I'm just going to sketch it roughly here. Came out like that. Now if you put them both on the same graph, since we've done this before, you should have a better idea about what's being created. Here they are on the same graph. What happens when you put them on the same graph? They intersect at 1, negative 1? Negative 1, negative 1 is right. So negative 1, negative 1, where else? 1, 1, where else? And 0, 0. What is special that is created when you intersect these graphs? Yes, they create a reflection like this. Those sides reflect each other through that line, and the same here creates a reflection. Here are the things to remember from today. Y equals the square root of x is a reflection of y equals x squared across the line y equals x when x is not negative. And I'll shorten this up so that you can still see it, but I can still draw here. Where you have this. And remember, the graph of x squared looked like that. And then the graph of the square root of x came out like this. When it says across the line y equals x, it is talking about this. That line is y equals x. That means x and y are equal. So that line has points of 0, 0, 1, 1, 2, 2, 3, 3, and so on. That line, y equals x, creates a reflection of those objects on either side. Here's a better version of what I just drew. I forgot I put that in there. Much better than my freehand drawing. The domain of y equals x squared, y equals x to the third, and y equals the cube root of x is all real numbers for each of those. And you must remember that for each. The domain of y equals the square root of x is x greater than or equal to 0. You cannot put a negative number in there because it will give you an error on the calculator. In Algebra 2, you'll figure out what you can do with a square root of a negative number. It's an imaginary number, not a real one. But we're not doing that in Algebra 1. The range of y equals x squared and y equals the square root of x, they both come out to be greater than or equal to 0. The range of y equals x cubed and y equals the cube root of x is all real numbers. They can be negative, positive, or 0. No limits on those. And for y equals x cubed and y equals the cube root of x, they are symmetrical about the origin. They are reflections of each other across y equals x squared, and the two operations reverse each other. And here's the graph of those that we just did. Those operations reverse each other, and there is the y equals x line of symmetry. Those objects reflect each other across that line. Alright, the homework. You have 1, 2, 3, 4 questions on this page. Do exactly what it says to do. And then over here create the graphs of p of x equals the cube of x, and then minus 2, and then the cube root of x, and then minus 2 after that. And then answer question 6. And then 7, 8, 9, and 10.